So the aim of this short video is to help you think about the signs of definite integrals. And it's going to be done through a question. Is the integral here from pi over 2 to b of cos of theta integrated with respect to theta always negative or 0? Is that true or is that false for all values of b which are greater than pi over 2? So is that true or is it false? If it's true, please explain why. If it's false, explain why or give a counter example. And I want you to do this by using a sketch. I do not want you to actually calculate the value of the integral, though you are, of course, at liberty to do that additionally. Okay, so what I suggest you do is think about it, and then after you've worked out your answer, you can look at the next slide and see whether we agree. Okay, let's pause here. Welcome back. Let's go on to the next slide. So this is the key idea. If we have an integral with some lower and upper integration limits, and I'm assuming that the upper integration limit is larger than the lower integration limit, so we're integrating from somewhere here to somewhere more to the right, then our interpretation is that you sketch the integrand, the function that we are integrating here, and if that function is positive, if it's above the theta axis, then this area here is the value of the integral from a to here, say. But if it becomes negative, then over this region, the contribution of the area to the integral is minus its value. So all areas are positive, but the contribution of this to this integral is minus a2. And then here, I've just shown it such that our integrand is becoming positive again, and this gives a contribution equal to this area. So for this arbitrary thing that I've sketched here, the value of our definite integral would be this area minus this area plus this area. So that's the basic fundamental idea. You sketch the integrand, and then when you have sketched the integrand, you can read off, perhaps, whether the integral is positive or negative or vanishes. So let's now use this to look at the exercise we started with. So this is the integral that we wanted to interpret for b being greater than pi over 2. And this is our integrand, the cosine of theta. So let us sketch what our integrand looks like. It's something like this. Goes up and down between -1 and 1. And I'll stop drawing it there. And this is y is equal to the cosine of theta. So as I said, its maximum value is 1, its minimum value is -1, and pi over 2 is here. The integrand reaches its minimum value of -1 here when the variable theta is equal to pi. It is 0 at 3 pi over 2, and it is 1 at 2 pi, and then we add another pi over 2. That gives us 5 pi over 2 here, etc. That will do for the moment. So if we're going to be integrating from pi over 2 to somewhere greater than pi over 2, but not that much greater, somewhere here, say, you can see that the integrand for this whole period is negative. So the integrand is below the theta axis. So if you were integrating up to, let's say, pi, then your interpretation of the integral is that it would be equal to minus the value of that area. As you then increase your upper limit of integration, so you go from pi to, let's say, 3 pi over 2, well, you're going to add the contribution of this area, but because it's below the theta axis, you get a minus sign. So as you're integrating from pi over 2 all the way up to 3 pi over 2, your integral is always going to be negative and its value is getting larger. So negative and getting larger. However, once you get above 3 pi over 2, your integrand starts to become positive. So we're above the theta axis. And at that stage, what happens is that we are adding on positive contributions. So if you're integrating up to 2 pi, say, we would add this. And that's making the result of the integral this negative contribution here plus this positive contribution. And then as you carry on, we're adding another positive contribution as we go on. And when we get to 5 pi over 2, you can see that this negative contribution and this positive contribution have the same size. They are equal areas, and their contributions to the definite integral would cancel. So at 5 pi over 2, this integral would vanish. So from pi over 2 to 5 pi over 2, the integral is 0. However, immediately after that, our integrand becomes negative again, and we receive more negative contributions. So if you were integrating here, say, this would be negative. Then as you carry on, this would be positive. So I'll change the color back there. This would be positive. And what we see is that this is going to continue this way forever. The integral is always going to be negative because we start off with this negative contribution, and then when the positive contribution here has the same size, the same magnitude, and they cancel, we're here, but that's immediately followed by a negative contribution, and that cycle will continue on forever. So we conclude that the integral from pi over 2 to b cos of theta d theta is less than or equal to 0 for all b greater than pi over 2, and it is only 0 at 5 pi over 2 when we have this and this cancelling. And then to go from here to here, we've added another 2 pi. 5 pi over 2 plus 2 pi is 9 pi over 2. So 9 pi over 2, and then the next one would be 13 pi over 2, etc. So without calculating the integral, though I encourage you to calculate it afterwards, we can see what the sign of this definite integral is. Okay, now what I would like to do is give you a couple of exercises to look at, so let's look to the next slide. So in the same way as the exercise that we've just worked through, I would like you to think about what you can say about the signs of these two integrals here and here. So the integral of sine theta from 0 to b for all b greater than 0, and the integral of sine theta from minus pi over 2 to b for all b greater than minus pi over 2. So again, draw the integrands with pen and paper, and then once you've done that, you should be able to say something about their signs. On the next slide, I'll give you the answers, but have a go at it first. That's how you get something from a video like this. So here are the answers that you should get. This integral, if b is greater than naught, from naught to b, is always going to be positive or 0. So for example, if b is equal to 2 pi, it will vanish. But generally for all points apart from 2 pi, 4 pi, 6 pi, etc., this integral will be positive. Coming down to this integral from minus pi over 2 to b, for b greater than minus pi over 2, the integral of sine theta with respect to theta does not have a well-defined sign. For example, if b is 0, the integral is negative. If b is pi, the integral is positive. So this can have both negative and positive values depending on the choice of b. With that, I'll stop this video and I hope it's helped you.